Hello, today I'm going to be talking about the electric EEW Pro. This is a high-end e-spinner that I've been working on for a while, and I have mentioned it in the past, but I just want to explain very briefly why I'm talking about it now. So it's very far out, probably a couple of years or so. I really don't have a very good estimate. Right now I'm still working on the R&D for it. I'm trying to bring a lot of features that have never been done before in an e-spinner, and just working through the issues that I'm finding. It takes time, and my other e-spinners are selling well, so I don't feel a rush, and I really want to give something back to the community and really sort of create a new type of e-spinner like I did with the Nano when I released something smaller. Only this time I want to bring some features that spinners have never seen before in the consumer market. So that's what I'm doing here. And why I'm talking about it now is because it's very critical for me to get helpful feedback from people while I'm developing it, so that I'm working on the right features and making sure that I'm spending time on the things that will help spinners the most. So there will be a poll attached to the description of this video, so please go fill that out after watching the video. It'll be very helpful for me. This is the electric EEW Pro in its current iteration. It's definitely not the final design. I'm going to be working on the visuals at some point, so don't worry too much about those. Right now I'm just working on what features to include, and that's going to be a lot of what's in the poll. So one of the major differences that you'll notice first off is the screen, and it is backlit. The extra power for that is no problem on an e-spinner, because most of the power is going to the motors. So the beeping you hear is just something that I have right now in the software to indicate that I'm getting the encoders turning right. So you can ignore that. This is a pretty good screen. This is an LCD screen, and I'm pretty happy with it. We've done a lot of testing with this one. This is a little bit bigger than the alternative I'm gonna show you right now, which is right here. So this is an OLED screen. I would like some feedback on whether people think, so the OLED screen is going to be, in quantity, this is about a $5 screen, and in quantity, this is about a $10 screen. So I'm just kind of curious if people think that there's a quality difference in the displays that sort of justifies that. Another downside of this OLED is this is the biggest one I could get at a reasonable price with the resolution I wanted, and it is a little bit smaller than the LCD. So I would like to, if anybody has strong opinions on one display over another, definitely let me know. I mean, I've done stress testing on both of them, so I know that neither one of them gets burn-in, if you're familiar with that, and they both work pretty well. The refresh rate on this one's a little bit better, but for what we're going to be doing, I think either one's really good. Let me know if you have an opinion on one of these two screens. I'd like to know what people think. I think I'm leaning towards this LCD right now. I just think it being a little bit bigger, it's a little easier to mount to the circuit board, which is nice, but I can figure that all out for the OLED too. So just let me know which one you think is better. So right now on this prototype, I have the Orifice hook right here, held in place by two magnets. I liked it on the front here, and there's space, because it won't get in the way of the flyer. It's easier to access whether you're right or left-handed, and you just stick it in there like you would on the electric EEW 6. Another option is to go with a loop design for the Orifice hook, and that would be more like the cone winder. So that's like a plastic loop that you can stick through there, and it sort of threads. Because by the nature of this, the length that you have to go through is longer than on the electric EEW 6. I plan to test both of them, and if one of them works significantly better, I'll go with that design. But if they work about the same, which I kind of suspect, I'd like to know if people prefer the wire hook or the loop Orifice hook. The next feature I'll be asking about in the poll is a level winding feature. So a level winding feature is something that automatically moves these hooks back and forth on the flyer, so you don't have to sit there and adjust them. And the way that I'm planning to do it is I have a multi-pulley system here, and one of the belts from here will turn this knob, and then this knob will move these hooks kind of like this. And this version actually is working worse than my previous prototype, and I understand why that is. That's something that I'm going to have to fix if the level winding feature is requested. And I think it will. I think it's been the most requested feature. So this is definitely something that I'm going to be cleaning up in the future. Another thing I'll mention about these hooks is these actually are a custom ceramic insert that I've been experimenting with, and I'm very happy with these ceramic inserts that I've designed and I'm using. These really work nice with these hooks. So once I get the level winding system working, then you can know that the way yarn flows through these ceramic hooks in my testing is much better than the hooks on the electric eel wheel 6. And actually, this might be something that I look to eventually migrate to an electric eel wheel 6 or something. These are working just amazing. But there's some issues taking these regards to weight on the electric eel wheel 6, but on the Pro, this flyer is made out of aluminum, and that makes it really strong and able to handle the extra weight of these hooks without an issue. Next, I want to show you that there's 2 motors connected to this e-spinner, and those are controlled by these 2 dials, one here and one here. And each one of those controls the speed of a different motor. One will turn the flyer, and one will turn the bobbin. And those are completely independent. I've got it set up to show you. We can spin the flyer this direction, and let's turn the bobbin in the other direction. Now, you wouldn't actually ever spin like that, but the point is it's completely configurable how these 2 spin, and it's completely independent of each other, and both are digital. So you get a lot more flexibility in how things are going to spin with regards to each other. And what I'm showing here is just the possibilities. Now, how well this actually works depends on software. And this is a feature I'm pretty committed to doing. I really think that with the proper software, that you're going to be able to do some pretty amazing things. Like you can definitely simulate a Scotch tension or an Irish tension. You should be able to simulate double drive. And then there's even more complex modes that I think you could probably expose in software. Now, I'm not sure what I'm going to expose. It may be that just exposing one of those is sort of the best, but I'm going to, play around with the software later. Right now, I'm just working on perfecting the software, and I'm pretty happy with how these motors are both responding. And in the software now, I'm going to be able to come up with different algorithms to make it behave differently. But there are things that come along with this kind of a design for free. Like oftentimes when you stop a bobbin, or you stop the flyer, if you have a heavy bobbin, it will overspin and kind of create tangles. With this, I can sense how fast the bobbin is going and how fast the flyer is going, and make sure that when you turn it off, they're always in sync. So you're never going to have those kinds of tangles. Then there's things that we could do, like making sure that you get a specific twist per inch target. So there's things that you can do with this that are probably beyond what I'm going to expose initially, but it'll let me expose something that I think is better than what has been released in the past, and then something I can expand on. And one of the reasons I can expand on it is it has this little slot here, and that's going to be an SD card, and I'm hopefully going to allow upgrades through that card of the firmware. So that means that if I ship it in one configuration and it doesn't have all the modes, or somebody wants to add another mode, then we'll be able to upgrade your software very easily at your house, just using like an SD card that you use with cameras and stuff. So anyways, those are sort of the grand plans for the motor. And again, I probably won't get all of it working in the very first version, but I will make sure I get enough that it's very impressive before I release it. And the magic there is going to be the software. I think it's actually going to be the most difficult part of the software of this project. Oh, one other thing is this screen that I showed earlier was just a debug menu that sort of lists a bunch of the different settings that I'm working on right now. The final one will be a pretty display and stuff. Just like the case I'm going to make prettier, I'm also going to make the displays prettier, or the interface and the menus and stuff. That's all software though, so I'll be working on that later. So one thing you can see here is there's a little hole right here. Not these big holes are just covers, and I think you're going to store a battery or something in there. But this little hole here is a distance sensor, and with that, I'm going to be able to measure how full the bobbin is. I think that's a pretty cool feature. It can work in combination with the motor controls to really help target a specific twist per inch, and also just help you know how full your bobbin is if you're not familiar with spinning. But I don't think really most people will be using that. I think it's more about advanced motor features, and it's not that difficult to incorporate. So I think I might include that, but again, definitely give me feedback in the poll on whether you think something like that is. So the reason knowing how full the bobbin is nice, is then we know the diameter of the yarn, and if we know the diameter of the yarn and we know how fast the bobbin is spinning, we know how many inches or centimeters of yarn are getting pulled onto the bobbin. Like if you pull, one revolution at the center of the bobbin, it might be like 3 centimeters, but one revolution at the outside might be 10 centimeters. So you really want to know how full the bobbin is if you're calculating how much yarn is going onto the bobbin. So also with that, you'd be able to come up with an estimate of how much yarn is on the bobbin. But I don't know how accurate that'll be. That'll definitely have to be something I have to test. I think it allows a lot of neat things, but again, it's the software that's going to sort of show how useful it is. Another feature is on the bottom. I don't actually have just regular rubber feet. These are actually load cells. It's the thing that you'd find on like your typical bathroom scale or your kitchen scale. And with that, you can figure out how many ounces of yarn are on your bobbin as you're spinning it, which is pretty cool. I do think that there's some downsides with that. So specifically, you have to calibrate it pretty frequently. And in order to do that, you're either going to have to remove the bobbin or put an empty bobbin on. And I think that's just going to get tiresome. So something that is completely new from last time is this back brace. Before, I just had the flyer and it kind of looked like that. And this works fine at lower speeds, but now that I have motors connected, I found that there is some vibration, and maybe I can fix that by redesigning the case some, or maybe when I go into the injection molded files, this piece won't be necessary. But I kind of think that I'm going to need something back here that sort of holds it in place. And to do that, I'm going to sort of ask people what they would really like back here. So I think like the major options are something that works sort of like this, where magnets hold it in place. It comes off pretty easy. This one's kind of hard to take off, but that's just the current design. I think that I could make it a lot easier to come off, and it would work pretty well. But another thing we could do is we could come up with some kind of a hinge back here. I think it actually has to pull out and then hinge. That'd be a bit more complicated, but if people think that something that hinges in the back would be better, definitely let me know that in the poll. Oh, and while I'm mentioning flyer speeds, in the poll I have a bunch of different speeds ranging. At the low end, we can go about the same speed as the electric eel wheel 6, and I can go up from there. It is a heavy flyer, so while I can get the motors that rotate it as fast as I want, I become a little concerned about how heavy things are getting. I could make a smaller flyer. That's what some of the other e-spinner companies do when they do high-speed flyers, and that would definitely work. But, I kind of wanted to do it all with one flyer, so I don't know. I'm kind of not sure what to do. But what would be helpful is if you fill out in the poll what RPMs you'd like to see the flyer spinning at. So I have comparisons of like the electric eel wheel 6 and then up from there. So yeah, please fill out the poll on that as well. And the last thing I'm going to talk about isn't actually shown here, but foot pedal wise. In the past, I've gotten a small number of people asking about an analog foot pedal. So the idea there is you could control it sort of like you do a sewing machine, where the more you press on it, the faster it goes. Now, if I did that, I would definitely keep a digital version, because I'm pretty sure most people prefer the on-off kind of foot pedal that I have on the electric eel wheel 6. So that will be included. But the question is, should I also allow the foot pedal to be a different mode, basically, where it, as you press it down farther, you go faster? If that's a feature you would like, let me know. So I think that covers all of the questions I've been having with the hardware as I've been designing it at this stage. I wanted to really get the hardware a little bit further along, probably do another prototype, and then I'll start working on the software a lot more. There's going to be a lot of work to do there. And then at that point, I'll have something that's, more functional, and I'll probably start talking to or letting beta testers try it out. There's no need to ask to be a beta tester. I've got a big list already. So unfortunately, I probably won't be getting new beta testers just for this spinning wheel, but I will be testing it with a lot of people. Maybe I'll have festivals, or maybe I'll have an open spin day at my workshop or something, and people in the Massachusetts area can come and visit. Anyways, that's enough for now. I hope you found this interesting. Please fill out that poll. That's really going to be helpful for me and making sure that I choose the right features to include in this e-spinner. Thanks for watching.